As far as we are concerned, we have different steps while doing oxidation number method, which we have done on the left side, oxidation number by structure. So first of all, we will write the correct formula of the reaction. Then we will identify atoms undergoing change in oxidation number, and we have to calculate increase or decrease in oxidation number per atom and for entire ion or molecule. If unequal, multiply by suitable number to make them equal on left and right sides entirely. Then we have to add H plus or H negative ion to make total ionic charges of reactants and products equal. So equalizing H plus on two sides by adding water. Then we have oxidation number method, in which we define the first one method of equations and the second method, which is half redox reaction method, is on the right side of the first method. So these include some steps: that separation of equation into two half reactions, then balancing atoms other than oxygen and hydrogen. For reaction occurring in acidic medium, we add H2O to balance oxygen atoms and H plus atoms to balance hydrogen atoms. Alright. Then we balance charges by adding electron to one side of the half reactions. Alright. When we do this, when we add electron to one sides of the half reactions in case of half reactions, in case of half reaction method, oxidation number arrangement, then we add two half reactions and cancel the electrons on each side. Afterwards, the last step is to be done. Afterward, the 5 steps being performed in half reaction methods, we scale the equation. We scale the overall equation that has the same type and number of atoms and same charges on both sides of the equation. The last step is very simple: scaling the equation, having same kind and number of atoms, and also having same charges on both sides of the equation. Then we have types of redox reactions, in which we have the first type, that is combination reaction. So let us move towards briefly and discuss combination reaction. In combination reaction, the reactants combine to form single products like hydrogen gas, oxygen gas, combining, making water liquid as a single product. Breakdown of a compound into two or more compounds like lime water. In case of solid, we provide a heat and the reaction is thus dropped down to the right side. So CaO solid plus CO2 gaseous substances are thus formed in the overall procedure of decomposition reaction. Then a displacement reaction, which is an ion atom in a compound is replaced by an ion per atom of another element, like copper sulfate aqueous form, zinc solid form. So the copper is being replaced here by zinc. So that's a kind of displacement or replacement reaction in which zinc being added to the aqueous solution of copper sulfate, replacing copper from sulfur with itself, and the resultant product we obtain in the reaction, which is replaced by zinc. So the product is zinc sulfate aqueous plus copper. Here they don't write the state solid, but it will be solid if it precipitates in the aqueous reaction. Then we have deproportionation, in which we have an element in one oxidation state that is simultaneously at the same time oxidized and reduced. Alright, like we have 2 moles of hydrogen peroxide or H2O2 liquid, the spirit. So whenever it reduces or ionizes in such a way that it gives us 2 moles of water liquid and 1 mole of oxygen gas. So that is a true deproportionation reaction kind. Then what is remaining, you can see in here: calculation of n factor, and rules for arranging oxidation number. So let us do this one. That is the simplest kind of topic in here. So oxidation number of single element is always 0. Oxidation number of ions is on only one atom. 0 n is equal to charge on ion. Oxidation number of oxygen is almost in most of the compound is -2, but oxidation number of hydrogen in most of the compound is +1, except when it is bonded to metals in binary compounds. So the oxidation number thus changes. Halogens have an oxidation number of -1 whenever they occur as halide ions in their compounds. So algebraic sum of oxidation number with all the atoms in a compounds must be entirely 0. Then what do you think the topic is that is remaining one in this concern? So I think the topic that is being remaining is the application of redox reaction in the calculation of n factor. So let me move towards the n factor first of all. N factor of oxidizing agent or of reducing agent, which equals to change in oxidation number per molecule, like the one in here, manganese oxide, ortho oxide, we have the +7 oxidation state in here, and here we have the +2 oxidation state. So change is 5x1 in here. So n factor equals 1 in this case. In this case we have carbon ortho oxide. So a case whenever this comes, so we say that +3, that is the overall oxidation state in here. So change of 1x2, the oxidation state changes to +4, or you can say 3 + 2, which equals to +4. So n factor here is 2, cause the oxidation state changes to +4, and here it is 5, cause it is changes to +7 from cause it changes to +9 from +7 in this case. So that's how n factor works. Then we have the topics mainly remaining. I think the electrochemical series is remaining and the application is remaining. So let us do electrochemical series first, because it's easy to be remembered first of all. Then we will move to our advanced topic. So a series of electrodes on half cells arranged in order of their increasing standard oxidation potentials or in the decreasing order of their standard reduction potential. Let us move towards the galvanic cell in here. You can see the galvanic cell. Galvanic cell is arranged in such a way that we have anode being placed in the right one chamber, and the cathode, negatively charged electrode, being placed in the right chamber and attached through a galvanic wire, in which we have the galvanic cell in here, and the salt bridge, which is the main attachment for the reduction oxidation balancing equation. Bridge mean it is a bridge between the two chambers. So we have in one reaction we have half reaction or half reaction method equation, oxidation numbering method. All the rules been discussed before, you can see them and review them. So oxidation half and reduction half here means that the overall redox reaction is being here divided by half or divided by 2, and the oxidation happens in this chamber and the reduction happens in this chamber, and they are attached by salt bridge with each other. That is how the electrochemical series works in case of galvanic reaction. Then we have the applications of redox reactions. The one galvanic cell we discussed, study of electrolysis of electrode processes and cells. Here we have two electrodes, let's say anode cathodes, negative and positively charged electrode. So their study is the basic application of redox reaction in here. So good luck with today's lecture. We will discuss anything if you need help with, but the overall discussion has been done, and it was very interesting talking with you, making a lecture for you. So it has been a very great fun for you, maybe, but it was great fun for me too. Then you have good luck and bye. See you soon. Good luck.